All right, good evening. So we've had some questions on how to read like the distance and time graphs, trying to figure out and uh, pretty much put words or put equations to what's going on here. So you guys were given kind of a graph that looks, okay, pretend that's straight. Okay, that's a little straighter. But you're given a distance, and then we have a time. And you had a graph that kind of looks something like, yeah, pretend this is straight. Something like that, right? We have our time. We just each one of these blocks is 1 unit, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so we have our graph. So you have to remember going back to like d equals rt. Well, what's the speed? The speed is r is equal to d over t, isn't it? So what we're going to do is say, well, our d over t, we've gone two units up. Okay, so we've gone 2 units up and then 2 units over. So we could say that the speed here, okay, if I can find my pen again, so I lost it. There we go. The speed is going to be 2/2. So the speed is 1 for the first 2 seconds. Okay, so we'll look at what happens between what happens at time equals 2 to time equals 4. Well, we stayed at the same distance. We're not moving anywhere. The distance remains at 2. So what's going to happen is that we didn't move. The time progressed. The clock changed, but the position didn't. So that speed is going to be 0. So look what happens at our third grouping here, right? We go from a distance of 2 back down to a distance of 1. So we went backwards. Okay. So again, we lost 1 unit of distance. We lost 1 unit here. So we have -1. And then how long did that take to happen? We went from 4 to 5 seconds. So that's still a time increment of just 1. So we ended up with a -1. Okay, same thing from second 5 to 6. When the clock goes from 5 to 6, we're not moving anywhere. Okay, we're not moving anywhere. So the distance here is going to remain 0. And then once we get to 6, we go back up to, we're not looking for the actual position. We're saying, well, the position is changing. So again, we go up 1, 2 units, and again, in a 2-second interval here, okay? So when I come down here to graph, if I just wanted to graph the velocity, okay, if I just wanted to graph the velocity here, okay, we would go through, let me scroll down a little bit more if I may. Okay. So if I'm just graphing the velocity here, so we're going to change this from a distance to a velocity graph. This is still time, but here we're going to be looking at velocity. We're going to be saying, I guess in the book it's a meters per second kind of an issue here. Okay. By the way, you should always label your axes in a word problem, especially in a word problem. Okay. From second 1 second, or from 0, 1, 2, right? What was my velocity over the first 2 seconds? Well, looking at this, my velocity over the first 2 seconds seemed to have been 1. So we're going to come over here, if I can find it. Okay. And over the first 2 seconds, the velocity, we're just going to graph it as a 1. First 2 seconds, it stays at 1. All right. Then look what happens at second number 2. From seconds 2 to 3 to 4. Are we moving anywhere? No. So this distance isn't changing. So my distance over time, okay, the distance isn't changing or anything like that. We're not moving new distances. So this top is going to be a 0. 0 over whatever is going to be 0. So we end up with 0 over 0, or 0 over 2, which ends up to 0. So I come back down to my velocity graph, come back down here. And from seconds 2, 3, and 4, we didn't move anywhere. Okay. And then it's up to you to put like little dots and little open holes here to like decide how that's going to work. Okay, I think the book does a much better job than my terrible looking graph. Okay, to tell you where the endpoints are and what's happening. So please see a much better drawing of a graph than what I've done here. Okay, because they're going to be a little bit more precise in what's happening. I hope this is giving you the general idea of what's going on. What's going on from second 4 to 5? Well, we decreased our distance by 1. So our top here, the numerator, is going to be a -1 over our 1. So our velocity is going to be -1. So what was our values here for time? Okay, time was between seconds 5 and 6. Okay, 2, 3, 4. This will be 5. That's between 5 and 6. We went down to -1. Okay, so here we were at 0. Now we are at -1. Okay, and then because my graph is not drawn precisely enough, I just decided that the beginning of time was going to be the open hole, so it's going to finish the clock at the even second, so it's going to finish here. We're not going to change the position. As soon as we think about moving the clock forward again, we're going to jump to the new position. Okay, and that's the kind of discontinuity is, right? It looks like we were on our graph and we jumped down 1. So when they ask you what kind of discontinuity this is a jump discontinuity. Okay, then we'll go back up here. Okay, and then between second 4 and 5, we were at -1. So let's go ahead and do that. Get my eraser out. Okay, so between second 4 and 5, we were at -1. Here we go. Again, I'll put a little open hole here. Go back upstairs, see what's going on up here. Between second 6 and 7 and 8, well, what's the change, right? Between seconds 6 and 8, it's 2 seconds of time. We are traveling 2 seconds or 2 units worth of distance over 2 seconds of time. So again, that's going to be the fraction 2/2. So my speed at that point is 1. So we go from 6, 7, 8 to 2, 3, 4, 5, 6, 7, and 8. We're going to go back up here, and it's going to jump back up here to there. So this is my graph, right? So it's 1 for the first couple of seconds, 0 for the next little bit. Then we go backwards. Okay, so we're down here. Okay, we're down here somewhere. And then once we start motion again, we start positive motion again, we're going to be back up here at a speed of 1. Okay, so this is my velocity. This is my time. Again, if you're doing this by hand, try to label your graphs so that people can tell what's going on. I think the book does that. So that gives you an idea of like how do you interpret these kinds of graphs. I'll be honest with you, the first time you see these is a little tricky. And then you'll see this like when you take your Calc 2, Calc 3, Physics 1, Physics 2, engineering or engineering statics for those engineering students, engineering mechanics. You'll see these kinds of graphs fortunately, about once a semester, maybe twice a semester where you have to interpret this thing. So it's almost always during the first week when you have to do this again. But even when you get to your engineering classes, this is not going away. It might be time versus force, and you're calculating your stress, something like that. So it may not always be a velocity. It often is. Okay, but this is the kind of thing that they're expecting you to interpret out of this graph. Okay, so I hope that helps a little bit. And I'm always happy to answer your questions, so let me know. Thank you.